Hey, welcome to dotnetFlix. Today, Sander, you're going to talk about SignalR, right?
Yeah, and especially the new Azure SignalR service.
Okay. So that's the new one that we heard about at Build?
Yeah.
Okay, cool.
And it's still in preview, so it hasn't been released yet. So let's talk a little bit about SignalR in general.
Yes.
Then I'm going to show you this demo application I've built using SignalR. And then I will add the Azure SignalR service to it. Then we can see what kind of benefits we can get from using that service in our application.
And that's a new service in Azure?
Yeah, it's a totally managed service that you can use. But just to take a step back and look at SignalR. So SignalR is this library that developers can use to add what they call real-time web functionality to their applications. And what that means is that your server-side code can push content to the connected clients as it happens in real time.
And that can also be a browser, someone sitting on a website and you can just push messages.
Exactly. So for example, a real-world scenario would be the Azure portal itself.
Of course.
Right? When you spin up a resource in the Azure portal, you get a nice notification that hopefully your resource has been provisioned successfully.
Or there was an error.
That
happens,
And those notifications are being pushed from the server to the client using SignalR.
Nice. Cool.
And basically SignalR makes it very easy for you to do that because it automatically figures out if it needs to use WebSocket connections or long polling, dependent on the features of the browser. So it does all that stuff for you.
So it falls back nicely to other technologies when the best of the best is not available.
Exactly.
It is makes sense.
But with great power comes great responsibility, and these real-time scenarios, they really require a lot of concurrent connections between the client and the server.
Because I can do this with millions of users, right? If I want to.
You can. If you've got an interesting enough application, you sure can. Right. So your server must be able to handle all those connections, and setting that up at scale while getting the performance you like to have. That's not trivial. That can be quite challenging. So wouldn't it be nice if you wouldn't have to worry about all of that stuff? And that's where the new Azure SignalR service comes in.
So you can just pay for it.
Yeah. Basically, you can just pay it up.
Nice.
And the service will manage all of those client connections for you.
Nice. And it scales out also.
Scales out, yeah. So basically, you're breaking your solution in your problem into two parts, right? You've got your server-side code where you can focus on your business logic, and then you've got the Azure SignalR service, which uses or which manages the client connections. You can scale those independently of each other.
Nice.
And now when you want to publish or push content to your clients, you just push it to the service, and the service will distribute it.
Okay. And
do
I always push to all my clients, or is there also a way to target specific clients?
Yeah, you can target specific clients. You can group clients together and target a specific group, and that's all basic SignalR functionality, and that's everything that's in SignalR is basically supported by the SignalR service.
Nice.
Yeah.
And this works on .NET and .NET Core?
So there are now two versions.
Of
SignalR. There's the original ASP.NET SignalR version, which has been around for a couple of years now. And there's a new version in preview. I believe they are at release candidate stage right now, which is SignalR Core for ASP.NET Core. And the service, the new Azure SignalR service in Azure, only works with the ASP.NET Core version of SignalR. So you need to make sure you are on Core.
That's a good tip.
Okay, so let me show you a bit of a demo.
Show me millions of clients.
Yeah, well, I've got one client, so it's almost a million, right?
Baby steps.
So this is my energy dashboard demo, and I've used this demo a couple of times. It's actually based on a real-world customer project I'm doing, and in the real-world project, it has this very beautiful HTML5 front end.
I was just thinking, which PO says I want to have ASCII art, but
I'm sticking with my console version.
This is your demo version, okay?
And so this is an energy dashboard. So this thing on the left side here is obviously a windmill. I haven't taken the time to animate it yet. This is an office building. Yeah, sure, I accept pull request. This is an office building, and this is a parking lot. And the idea is that this application receives external data, either telemetry from the electricity meters or charge records from the charge points, and then it will update this dashboard so we can see what's going on. And companies can use this to be transparent to their customers or to their employees about their energy usage.
Cool.
Right. Okay. So there are two parts to this application. This is our client. So I'm not using a web browser here, but just this console application. And at the server side, I'm using a Service Fabric application.
Okay.
And it's actually being implemented using the Reliable Actors programming model. So first of all, let me prove to you that this thing actually does something. So I've got a web API here, and we can simulate a electric car parking and starting to charge by putting a request to that API. So first of all, we need to get the endpoint of the API. So as I told you, I'm running on Service Fabric, and I'm running Service Fabric local here on my machine. So I'm running on my local cluster. So we can go to the Service Fabric Explorer, and there's the server side of my application. It has a gateway API, and I can just look at the endpoint address here. So this is the endpoint where my API is listening. So let's copy that. Switch over to Fiddler, move this guy a little bit to the side here. And now we can make a put request to my API. So my API is at /API/charge point / and now I need the ID of a specific charge point. And let's just choose charge point 1, which is this green box here.
So it's available now, and
it's available for parking. It's free. Yeah. And now we need to send an event to that, and payload's really simple. It just has a single event type property which says, hey, a session has started. So somebody has parked his Tesla over there and has plugged into the charge point. Okay. So if I execute this, then what you see is immediately real time, right? This dashboard is updated. So what happened here is the HTTP request was processed by the server. Server did some calculations, created an updated version of the dashboard, and used SignalR to push that new updated dashboard down to the client application.
And when this dashboard was started, it did some kind of registration to the server to make sure that it is known and it can receive messages from SignalR.
Exactly. I'll show you in a minute.
Cool.
So one thing to notice here in Fiddler is that in this pane on the left here, you see all the incoming outgoing connections. And I'm actually filtering there for WebSocket connections. So you do see my HTTP request here, even though it isn't a WebSocket connection, because by default Fiddler always shows the request that you compose yourself. But I don't see any WebSocket connection here now between the client and the server. And that's because both the client and the server are running on my local machine, and they aren't going through the proxy that Fiddler is using.
Makes sense.
But that will be important later on when we start looking at the Azure SignalR servers. Okay, so let me show you some of the code that I needed to write to make this work with SignalR.
All the millions of lines of intricate code that you had to come up with, right? Or
it's much easier than that.
Okay, cool.
So
even I can do that.
Oh, I'm not going to say anything about it.
Wise answer.
Okay, so I've got my solution here. And let's look at the Gateway API, which is the project which implements my web API. And so first of all, I would need, of course, add a reference to the SignalR library. So as you can see here, I'm using Microsoft.ASP.NET Core.SignalR. So I'm using the ASP.NET Core version of SignalR.
That's a release candidate version.
Yeah, it's a release candidate. So it's not quite ready yet, but it's getting there.
Is it go live or?
Not sure.
Okay.
Not sure.
You can look it up.
Or tweet David Fowler. Then what I did was add a dashboard hub class. And the dashboard hub derives from hub and is basically my representation of my SignalR hub in the application. Now I don't have any code in here because this is just very simple demo, but you can add some code. For example, to execute when a new client is connected, when a client is disconnected. So you can You can push the notification that says, hey, somebody joined or somebody left the chat room, stuff like that.
Or initialize something or whatever.
Exactly.
Okay.
Okay, so that's my dashboard. And then I need a way to, whenever something happens on the server side, because if there's new incoming data, I need to call this hub to send out some messages.
Yep.
And I'm using reliable actors on server side, and I'm using reliable actor events to get notifications in my server side application when something has changed. And with reliable actor eventing, you need to create an event handler. So this is my iDashboard events is my event contract. And my dashboard event handler is my event handler for those events. And what you see here is that I'm using a bit of dependency injection, basically standard ASP.NET Core dependency injection, to get a reference to my dashboard hub within a hub context. And then whenever an actor gives me a signal of, hey, the dashboard is updated, I can use that hub context to send a message to all the clients. And here I'm sending it to all the clients, but of course you can send it to a single client or a group of clients or what have you. So that's basically all of the code. There's a little bit of initialization code here in my startup class. So I need to configure the services for dependency injection. So I need to do services.add.SignalR. And then I need to make sure it's registered in the request pipeline. So I've got here the app.useSignalR. And then I'm telling it that add/dashboard, map that route to the dashboard hub class that I've declared. So that's it for the server side.
And to be perfectly clear, you don't need to run anything in Service Fabric, right? This is just an ASP.NET application, core application.
Exactly.
You can run it in IIS, in Azure, whatever.
Exactly. So this was...
has nothing to do with Service Fabric.
Exactly. So this was a Service Fabric application before I added SignalR.
Yeah, makes sense.
So if we switch over to the client side, I've got this test application, Dashboard UI Core. So this is my console application with all the very expressive ASCII art in it. If you look at program.cs, and basically I've got the same reference to the same library here, ASP.NET Core version. But I'm using a hub connection builder here. I'm giving it my URL. So basically this is the endpoint of the API we just looked up in the Service Fabric Explorer. And here you can see that I want to listen to the route we just registered in the startup class. And then I can say, okay, build me a connection for that. And then I can configure that connection. So whenever I get an event called message, that I know that I'm sending a dashboard status over the line, do this stuff. And this stuff is basically redraw the entire dashboard.
Makes sense.
And then I can tell that connection to start. And it will set up the WebSocket and it will start listening and everything will work.
Okay.
So
I don't, by the way, see any authentication or tokens or stuff. Is that a choice, or is it just that you can connect to from every client to a hub if you know the endpoint?
So basically in this application, if you would like to add authorization, you can just add authorization or authorize attributes to the dashboard hub class, to the web API. It's just that because it's a simple demo application, I didn't implement it.
But it is possible.
It is possible.
And then you use the ASP.NET Core authorization model to do that.
And the same is also possible when later on you're using the Azure SignalR service. You can just use OAuth and all the normal authorization attributes that you're used to using.
Cool.
Okay, so talking about Azure SignalR service, this has all been just plain SignalR, right? So let's look at how we can very easily integrate the Azure SignalR service with this project. And for that, of course, first step, it's a managed cloud service up there in Azure, so we need to go to the portal to create a new instance. So let's switch over to my Azure portal. We're clicking on create a resource. We need to search for SignalR service. So there it is. Click create. And then we just need to enter just a couple of details. So obviously we need to have a good name for the resource, something you can remember later on. We need to create a resource group. Choose location. So We're still in preview.
Yeah.
So there's just limited set of locations here.
But we're in West Europe, so that's cool.
We're in West Europe, so everything's fine for us. Right. We need to select the pricing tier. So there are basically 2 tiers available right now. You can choose a free tier, which gives you a single unit. And that single unit can handle up to 100 concurrent connections. So you can serve 100 clients with this free tier. And then you can move up to the standard tier, which gets you 1,000 connections per unit, but it also allows you to scale out. So you can have 10 units, so 10 times 1,000, you can have a maximum of 10,000 clients.
Okay. I also see SSL, so that's also not available in the free tier then.
Yeah.
Okay.
And so 10,000 connections may not be nearly enough for your $1 million project, but this is still preview pricing and preview tier, so there will be more pricing tiers available when this GAs. Okay. So let's just go for a standard tier, and then if you select standard tier, you can also choose how many units you'd like to have. And then you can click create, but of course we're not going to wait for that. Yes, discarded, and I've created a resource already. It doesn't take very long though to create a resource, just a minute or so. So let's go to my SignalR test resource group, where I've already created the SignalR test SignalR servers. And here in the overview you can see some nice graphs. You can see the number of connected clients, the number of connections, and you can see the average message rate over time. And we've got a couple of other interesting things here. We've got the keys, which are obviously very important because we need these keys to connect to the servers. So, because I will need this later on, I'm just going to click copy. So I've got it on my, what's it called?
Clipboard.
Clipboard, yes, thank you. We can enter our scaling settings here. So we can either scale up by changing pricing tier, and of course scale down if you want to move down. Or we can scale out by changing the number of units.
Okay. Does it incur any outages, or does the service just keep running and scales up or down?
Yeah,
as
it doesn't incur any outages, so it will keep running. Of course, if you've got 1 million clients connected and you're scaling down,
of course,
some connections will get broken. Yeah. Okay, so that's basically the most important stuff in the Azure portal. So it's a really simple service. Very easy to set up. Okay, now let's switch over to the code and see what kind of change we need to make to our own code to integrate with this service. So first of all, let's go back to my CSPROI for my web API, because we need to add an additional dependency. We need to add this Microsoft.azure.signalR package, which is also still in preview, obviously, because all services are still in preview. But we need to add that one, and then we can go to the startup class, and we've got our configure services with our add SignalR, and we just need an extra command here to tell it to use the service. So we need to add Azure SignalR. And then one of the overloads I can give my connection string. So I'm just pasting in my connection string here. Now obviously in a real world situation you will probably want to store this in configuration somewhere, and if I don't give it a connection string explicitly, it will try to find it in my app settings, so you can use that as well. Cool. And the other thing I need to do is, instead of use SignalR, I have to tell it to use Azure SignalR. Wow. And that's it.
That was a lot of work, man.
I'm done. Phew.
I'm pretty sure I can do this.
Yeah, I'm pretty sure you can. Okay, so let me restart it. So this is being deployed to Service Fabric right now, and this is using application refresh mode, where it doesn't need to make a whole package, but it just needs to copy some binaries, so it should be fairly quickly.
The biggest change is now that formerly you ran the SignalR hub in your application, and now you connect from the server side to the Azure hub, to the Azure SignalR
exactly.
hub.
So when somebody connects, when a new client connects, that connection attempt is still coming in to my server, because I need to do authorization there. I may have some code in the unconnected method, but then when the connection is accepted, it is offloaded to the Azure Signal servers.
Cool.
And we can see that In Fiddler. Because there are no WebSocket connections here yet, but now when I start my test application, and it will set up the connection.
Yeah. So you don't even have to change anything in the client. You just
Right.
connect to your server.
I
That's
didn't
pretty cool.
change a single byte of the client.
So the Azure is actually kind of a backplane for SignalR to do all the connection stuff.
Exactly.
And all, okay.
Exactly.
So there they are.
Here's my WebSocket connection. So you can see I'm tunneling to SignalR test service.signalr.net.
Yeah.
And basically this still works. So right now this place is taken, but if I send it a session ended event, then the parking spot has become available again.
Pretty cool.
And if I click on return in my console app, it will automatically start pushing some random data, and we can simulate a lot of traffic in our parking lot.
And can I see that now real time in the Azure portal, or does it take some time to?
I'm not sure. You should be able to see it in the Azure portal. I'm not sure what the refresh time is. So
there's already something coming in.
So we've got a connection here.
Yeah.
And our message array doesn't seem to be updated yet, although maybe a little bit. So it's coming. So it's fairly quick. It updates fairly quickly.
Cool.
Yeah. So this is it's really nice that you don't have to worry about all this stuff anymore. That you can just let Azure handle all the scalability issues for you.
Yeah, and you don't have to change the clients, because if you have millions of them, you can just say, okay, we don't have to change any lines of code. You can just connect, but I will offload all the SignalR stuff to Azure. So that's pretty
exactly.
Cool. Nice.
And one of the cool things this also enables is the whole serverless stuff.
Of course, yeah.
Because if you're writing an application on the Azure serverless platform and you're using Azure Functions for your APIs, Azure Functions only run for like 10 minutes at the most. So you cannot maintain those long-lived connections within an Azure function. Yeah. So now when you can offload those connections to the servers, you can do it in a completely serverless way. And there's actually a pretty cool GitHub function binding for the Azure SignalR service by Anthony Chu, which you can use if you want to start playing with that. So we will add a link to that in the show notes.
Awesome.
Yeah.
Thanks, man.
You're welcome.
I really like this. I want to pay for this. This is a cool service in Azure.
You will get the opportunity to pay for it when it GAs.
Cool. Thanks so much, and see you next time. Bye-bye.
Bye.